last topic for counting techniques, which is the combination. Combination. In some cases, we are interested in the number of ways of selecting our objects from n distinct objects without regard to order. So this selection is called combinations. Okay, the combination for any positive integers n and r, and the number of combinations of n distinct objects taken r at a time is this equation. So this is read as n taken r, or n combination r, which is equal to n factorial over n minus r factorial times r factorial. So for example, how many different combinations can be formed from the letters A, B, and C if two letters are taken at a time? So there are n, or three distinct letters, which is A, B, and C, and R, which are two letters that will be taken from three distinct letters. So our R is equal to 2. So n combination R, or 3 combination R, or shall we say 3 taken 2, you have 3 factorial over 3 minus 2 factorial times 2 factorial. So that is 3 factorial over 1 factorial times 2 factorial, which is 3 times 2 times 1 over 2 times 1. So we can just cancel 2 times 1. So we have 3 ways. So hence there are 3 different combinations of letters. Another example. From 4 mathematicians and 3 statisticians, find the number of committees of size 3 that can be formed from 2 mathematicians and 1 statistician. So this problem involves 2 counting techniques. So first is the fundamental principle of counting and combination. So there are actually 2 operations in this problem. So choosing 2 committee members from 4 mathematicians, then choosing 1 committee member from 3 mathematicians. So we will use combination for choosing the first operation, and we will still use combination for the second operation. Then we will use FEC to find the total number of ways for selecting this. So to find the number of ways of choosing 2 committees of committee members from 4 mathematicians, we will use n sub 1. So n sub 1 will be 4 combination 2. So that is 4 factorial over 4 minus 2 factorial times 2 factorial. So that is 4 factorial over 2 factorial times 2 factorial. So this will be equal to 6. Okay, to find the number of ways of choosing 1 committee member from 3 statisticians, we will use n sub 2. So n sub 2 will be 3 combination 1, or 3 taken 1. So that is 3 factorial over 3 minus 1 factorial times 1 factorial, which is equal to 3 factorial over 2 factorial times 1 factorial, which is equal to 3. So by FEC, we have n, which is equal to n sub 1 times n sub 2, which is equal to 6 times 3, which is equal to 18. Hence, there are 18 ways to form a committee of size 3 having 2 mathematicians and 1 statistician. So, what are the difference between the second property of permutation and the combination? So this one is defined as the different ways of arranging r objects out of given n objects in a particular order. While in the combination, this is defined as the different ways of grouping or selecting r objects out of n objects where order of the object does not matter. So let's take a look at this example. So earlier we select two letters from A, B, and C. So if the order matter and the order does not matter. For letter A, we will use permutation. And for letter B, since the order does not matter, we will use the combination. So obviously our n is 3 since we have three objects, A, B, and C. And R is equal to 2 since we will get two letters out of this 3. So again, for letter A, since the order does matter, so we have n permutation R, or you have 3 permutation 2. So using the formula for the second property of permutation, we have 3 factorial over 3 minus 2 factorial, which is just equal to 3 factorial over 1 factorial. So that is 3 times 2 times 1 over 1, or we have 6 ways. So that 6 will be AB, AC, BC, CB, CA, and BA. If the order does not matter, we will use combination. So you have n taken r, or you have 3 taken 2. So using the formula, you have 3 factorial over 3 minus 2 factorial times 2 factorial. Or you have 3 factorial over 1 factorial times 2 factorial. So that is 3 times 2 times 1 over 1 times 2 times 1. So canceling out 2 times 1, so you have 3 divided by 1, which is just equal to 3. So there are 3 ways. So what are the 3 ways? So you have AB, which is just equal to BA since the order does not matter. So this will be counted as 1 in combination. And AC is also equal to CA since the order does not matter. So this can be counted as 1. And we also have BC and CB, which is just counted as 1 because the order does not matter. So that's it. Thank you for listening. If you have more questions, please do not hesitate again to ask your instructors. So stay safe.